Hi everyone. Here we have a question that reads, if a woman takes an early pregnancy test, she will either test positive, meaning that the test says she's pregnant, or test negative, meaning that the test says she's not pregnant. Suppose that if a woman really is pregnant, there is a 98% chance that she will test positive. Also suppose that if a woman really is not pregnant, there is a 99% chance that she will test negative. Suppose that 1,000 women take early pregnancy tests and that 100 of them really are pregnant. Suppose that a woman from the group in A tests positive. What is the probability that she really is pregnant? So to answer this question, the first thing we can do is we can try and highlight the important parts of this question. So the first thing you can see, guys, is that there's two events here. The first event is that the woman is either pregnant or not pregnant. The second event is that the woman tests positive in the pregnancy test or tests negative. So since we have two consecutive events here, the way I like to answer this type of questions is always to start off by drawing a tree diagram. So let's do that. So once again, we have two events. So the first event is that the woman is really pregnant versus not pregnant. The second event is that the test is positive versus test is negative. I can have the same thing here, that the woman is not pregnant, but the test is positive versus test is negative. So after we have this kind of a basic structure for the tree diagram, we can try and find the probabilities for these branches. So the first thing you can see, guys, is that there is this value here, 98% chance, and that is the probability that given a woman is really pregnant, there is a 98% chance that she will test positive. So we're talking about really pregnant, and so testing positive given that the woman is pregnant. So the probability for that is 0.98. So the probability of testing negative given that the woman is pregnant is going to be 1 minus 0.98, which is 0.02. Now the second probability that we have here is that suppose if a woman really is not pregnant, so you're talking about this branch here, there's a 99% chance that she will test negative. So testing negative given the woman is not pregnant is 99%. So that's 0.99. So here it's going to be 1 minus 0.99, which is 0.01. Now this says, suppose that 1,000 women take early pregnancy test and 100 of them are really pregnant. So then the probability of being pregnant is 100 out of 1,000, which is just 0.1. And so the remaining probability here is 0.9. Okay. So we have the complete tree diagram. Now let's answer the question here. The question says, suppose that a woman from group A tests positive. What is the probability that she really is pregnant? So the condition here, guys, is that the woman is, we already know that the woman tested positive, and we have to find that the woman is really pregnant. So this is a conditional probability. And the way we can write that is we can say probability that the woman is pregnant given that she tested positive. Okay. And this is a conditional probability. And the formula to calculating the conditional probability is probability of A given B is equal to probability of A and B over probability of B. So if I wanted to write that here using the formula, so I can go back down here. So I can say this is the probability that the woman is pregnant and test is positive over probability of B, which is probability that the women tested positive. Now let's go and try and so I'm going to copy this over to the next page. So let's look at our tree diagram to figure this out. What is the probability that the woman is pregnant and tested positive? So pregnant and test positive is, we're talking about this branch. So we just have to multiply, because we're talking about and here, we just have to multiply pregnant 0.1 times 0.98. So that's 0.1 times 0.98 over the probability that the women tested positive. Now, if you look at the tree diagram, there is two ways that a woman can test positive. So either the woman is pregnant and tested positive, or the woman is not pregnant and tested positive. So you can write down those two branches. So you can say probability pregnant and test is positive, or probability not pregnant and positive. So to calculate that, we can just multiply those two branches again. So 0.1 times 0.98 for the first outcome, that the woman is pregnant and test positive. So 0.1 times 0.98 on the numerator, and on the denominator we start off with the same thing, 0.1 times 0.98 plus not pregnant and positive. So not pregnant and positive is this branch here. So that's 0.9 times 0.01. Okay. So I'll copy this over to the next page again. So from here, it's just calculations. So 0.1 times 0.98 gives us 0.098 over 0.098 plus 0.9 times 0.01. So that's 0.009. So the total probability here is that 0.098 over 0.098 plus 0.009, which gives us 0.9159, rounded to 4 decimal places.